Violet, we have a 2D LiDAR, so it just has an XY coordinate, but you can kind of have a 3D LiDAR, so that gives it, an XYZ coordinate, so you can see what's above and below the robot and kind of have, a more detailed map. And then, there's loads of other different types of sensors, so you can have 3D stereo depth cameras. They kind of give you a more granular view of what's going on and would be more likely used for the local cost maps. So on Violet, we use Intel RealSense cameras. So that tells Violet what exactly is in its immediate vicinity so it can move around it easily.
So the robot has to take all these sensors, actually kind of like an autonomous vehicle, the self-driving cars. You got LiDAR, you've got cameras, you've got other, probably, temp sensors, things like that. And from all that, it's got to create a map, a visualization of where it is and where it needs to go. So there's probably, quite a bit of processing power on Violet.
Yeah, so Violet definitely needs a lot of processing power. And at Akara, we really quickly realized that, our Intel NUC or computer that's on the robot mightn't be able to manage all these different algorithms. So we looked at what's called AI at the edge. So this kind of idea that you can run these heavy algorithms on small embedded hardware devices. So an example of that is the Intel Movidius compute stick, or you can use an NVIDIA Jetson or a Google Coral. So you don't have to rely on forking out for a super powerful onboard computer or worry about draining the robot's battery. They're also super cheap. A compute stick, I think, is about €100. And last year, Akara were actually part of the Intel Movidius Accelerator program in Dublin. And we were able to convert all of our algorithms into OpenVINO, which is the software that runs on the Movidius stick. And we were able to go from running all of our algorithms at 15 frames per second to over 30. So it really made a huge difference just kind of moving to this.
Yeah, so just changing platforms doubled your performance.
Yeah, exactly. It was really great.
From a machine learning standpoint, we've talked about all the mapping algorithms, and it sounds like you're doing the a lot of the image detection and recognition in dedicated hardware. What other sorts of algorithms, what other sorts of things are you asking Violet to do, just in its daily work?
Yeah, so I guess one of the things that kind of makes Violet different from other UV disinfection robots is that Violet can work alongside people. So Violet has 360-degree view cameras and is able to onboard run person detection algorithms to be able to detect whereabouts in the room a person is, and can kind of move its light shield away from the person because UV light can be harmful to eyes and skin, and is able to kind of update its navigation to move away from the person. Also, we kind of realised that, we would love to have feedback in terms of how clean a room is or how much UV dose a certain surface has, and then maybe update the navigation based on that. So the next time Violet cleans, it knows where it spent most time the previous clean, so can kind of update its path. Yeah, so that's something that's kind of new technology we're working on at the moment. And then, that will all feed into the navigation system. So it's not just kind of one navigation algorithm, it's multiple algorithms. Kind of, you have the global planner, the local planner, you have the person detection feeding into it. And we hope to kind of have this UV dose readings, updating and improving the path over time. So we kind of have this idea of data-driven cleaning. And I guess that's something that, kind of really excites me, the fact that it's, getting better over time and the robot's kind of learning and improving things.
Yeah, that really is interesting because, we expect robots to basically, do the same thing over and over again. Obviously, from traditional robotics, that is what they do. They take over a lot of the repetitive tasks that they're expected to do the same thing over and over, whereas you're asking Violet to actually learn based on the previous cleaning and do things differently each time, potentially.
Yeah. And it's really interesting how, different robots and different industries have different problems they want to solve. So, we're looking at making cleaning better and improving cleaning, whereas you look at like Amazon and they have these giant warehouses, and what their problem is more focused on is like one warehouse might have 8,000 robots, but they build their own warehouse. They can make the lanes as big as they want. They can, so their issue isn't really navigating from point A to point B. It's actually having all these 8,000 robots not crashing into each other. It's just such a different problem because they can have control over actually the navigation algorithm. But, there's so many of them moving. They kind of have, and it's not my area of expertise, but they would put a lot of focus on managing kind of swarm and like multi-agent algorithms. And I've kind of been reading about them. They have this kind of cloud infrastructure, and they kind of work like an air traffic control where they have the coordinates of the route of every robot, and they can kind of have this mass delivery robots kind of moving all around at once and never crashing into each other. I'd love to actually see it.
Yeah, that really is interesting that, we've got, AMRs, primarily in warehousing and logistics, but obviously we're seeing them in other industries, a lot of places, healthcare, hospitality, things like that, where the definition of autonomy and mobility is completely different from scenario to scenario.
Yeah, exactly. And like different focuses are needed for the different applications. So if you have a service robot, or even one that's more like Violet that the general public will be able to use, like the UI and the user experience is a lot more important. I think it's being kind of pushed with autonomous cars, and like now every car nearly has like a UI or some kind of interface that you interact with it. Like I don't think I could park anymore. I don't think I could park my car unless I had that reverse camera on the car's UI. But the same goes for robotics. Like now the general public are kind of starting to interact with them more. Like you'll see the service robots in restaurants bringing your food, and people are starting to use them more. So a lot of effort now and a lot of focus has gone into kind of UI design. And we do a lot of work with kind of human-robot interaction, or HRI. So, what is the best way that someone can tell Violet to stop cleaning, or, start a clean, or kind of get information from Violet? And it's kind of a really hard thing to kind of decide. So we first started off with a robot UI that as engineers we thought was brilliant and really easy to understand, and brought it to the user, and they were just like, what is this? I don't know what's going on. Why is there a Linux kernel here? But yeah, it kind of opened our eyes that, we really need to make this easy to use, or people won't use it and it won't get adopted. Like one of the biggest reasons a technology won't get adopted is because people find it too difficult to use.
Right. Yeah, absolutely. And that's that's even, going beyond simple safety and simply making sure that the robot doesn't run into anybody. This is now, how do you make the robot listen to somebody? Yeah,
exactly. And like speech interfaces are becoming a big thing. There's kind of a controversy over whether that is the best way to go. Should we just stick with using a screen UI and actually having someone go over and move it? Or, should we move to voice control? The natural language processing algorithms have like really advanced in the past 5 to 10 years, that, it's becoming easier to implement them. There's a lot of open source libraries that you can use. But I guess, one of our robots, so we don't just have a UV disinfection robot, there's kind of some other things in the background that we're working on. And one of the robots makes a bit of noise, and we were kind of testing a speech interface. And when the robot was on, it couldn't actually pick anything up because it was so noisy near the microphone that you couldn't hear it. So yeah, it's kind of, you think something will work and then you try it in the real life and it doesn't.
And that actually brings up another point is, last year during this podcast, we talked to a professor, Natarajan, at one of our local universities here. And he mentioned that, you can train and plan and whatnot, all your algorithms and your machine learning. And then when you actually get it out there, you really have to really, it undergoes a whole nother change in practical use.
Yeah, I 100% agree with that. And, I was actually nearly taken aback when I first got into robotics that people didn't just build things in simulation and then let them go into the wild and they worked perfectly. It definitely, we've definitely had cases where everything works really well in the lab and then you bring it into the real world environment, like a hospital, and things don't go to plan. One area in particular that I've noticed that happens a lot is kind of around the sensor suite. So like if you have a LiDAR on your robot, they're really affected by kind of the lighting conditions and, they can't detect surfaces like glass. And it's kind of hard to replicate the environment it will be in. Or a 3D stereo camera can sometimes have these kind of salt and pepper noise and in certain lighting. So kind of knowing the limitations of your sensors in certain environments and, being able to compensate for that. So say if the LiDAR isn't good in a certain situation, then have kind of a backup sensor of the 3D stereo camera, or by using like sensor software filters. So, being able to make sure your readings are as accurate as possible can really kind of give you a jump ahead around those potential issues. You just never know what's going to happen, but you can kind of preempt a little bit in terms of sensors. But we also kind of had that issue with kind of some of the training we did with our models. So we were originally using kind of some pre-trained models for detecting people, but we found out that kind of during COVID, obviously everyone in the hospital was wearing kind of heavy PPE and, it looked a bit different. And, we had to actually go back and retrain the model and add in kind of, but yeah, so, you kind of forget that, okay, the training set that this model's trained on was probably even before COVID and definitely didn't have people in it with PPE. Like it would pick them up sometimes, but then you kind of need to give it a little bit of help to be able to pick up on those things.
Right. So the models are actually so accurate they can tell the difference or actually be confused by, somebody not wearing a face shield or versus somebody wearing a face shield and a heavy N95.
Yeah, exactly. They mightn't know that they're a person. Yeah.
Yeah, I figured, okay, you get the rough outline. Okay, we got body and, we person, don't go that direction. But to get down to the level where, the robot needs to distinguish between somebody with a face mask, somebody without a face mask, so on. That's really interesting.
There's a lot of pre-trained networks came out that were able to detect, if someone was wearing a face mask or not. So like I think a lot of the community, that was probably something that was really needed to detect if someone's, being safe and wearing PPE. But there's a lot of pre-trained networks out there that people have already created that can actually do that.
So going back real quick to kind of to the safety, this topic of safety, we've talked a little bit about, avoiding people. Obviously we don't want Violet to go crashing into somebody, nor do you want Violet to actually give somebody a tan with the UVC light. But, are there other types of, since you're working so closely with people and people who are, like you just said, who are maybe not used to being around technology, are there other things that really that you guys have taken into consideration to be able to create that safe environment?
Yeah, so for Akara to sell a robot in Europe, we need to have what's called CE marking. So we need to make sure that Violet meets the machinery directive. And this requires us to perform a detailed risk assessment where we need to identify all the things that could go wrong. And then we need to look at how we could mitigate against each of these things. And a part of that, obviously, is the robot's safety system. And although we can do a lot with AI, we kind of can't rely just on software as a safety system. So there's, on Violet, there's kind of 3 levels of safety. So the first one is Violet's SOPs, so the standard operating procedure on how to use Violet. So we have kind of safe and repeatable instructions on how the operators can actually use the robot, and only trained operators can use and control the robot. And we run a lot of kind of staff training to make sure that they are using it up to code. And then there's like additional safety procedures that the operators will have to use. So UV radiation is regulated, and there's a threshold of over an 8 hour period of how much you can have shining on you or be near. And so our safety procedures do require that safety gear is worn to protect skin and eyes. But we also have these kind of wearable sensors. So you just wear the sensor and it measures the UV dose. So, if you are getting any UV dose, it will kind of beep and you move back away. And then only then kind of does the actual like software kick in after. So we kind of have the computer vision for safety, so being able to detect if a person is in the room. You can have it on a certain setting so that it will just turn off the light if there's a person in the room. Or we have then as well to make sure the robot doesn't go near a person or have a crash. We have the navigation system. You have the software that stops the robot before it hits an object, but then we also have like a safety rated LiDAR which automatically is connected to the motor controller that will stop the robot as if it's within a certain distance of an object. And then you kind of have the last line of defense, which is a bumper on the robot, kind of like the Roomba uses, which is you don't want to go that far, but it's like
we
all
hope
else
not.
fails. Yeah, exactly.
But
so
we get the last
like,
panic button.
Exactly, yeah. And then there also is like a big red button emergency stop on the robot.
Oh, there is really one, okay.
Yeah, so that's part of like the CE marking, and you have to have all these things. So it's really kind of like a hurdle effect. So there's so many different layers of safety that it's almost impossible that it will, that an accident will break through all of them. So it's not just one single thing. It's kind of a multitude of safety procedures that protect it. Just
different shells of safety. Some of them based on software, some of them based on hardware, such that so there's really no way for Violet ever to really have an accident. So you guys have developed Violet. I know you guys are in some deployments, and when you go from a single Violet, a single hospital to thousands of them, does that change the way you guys approach the robot or the service or system in general?
So yeah, that's something that we're just beginning to look into now. So we're still at kind of the early deployment stage, but now our early deployments, we're starting to add robots to a hospital. So the plan, I guess, is to have maybe around 10 to 20 robots per hospital. And it wouldn't be like kind of in Amazon warehouses where it's like a hive mentality. They won't be working side by side. They'll be largely independent. But we really do need to manage and maintain each robot remotely so that, if something goes wrong or, we can kind of anticipate their usage, or maybe one robot in one area is being used a lot more, and we could maybe kind of add another robot in that area. So what we're working on now is kind of building out a cloud infrastructure so that we can manage our fleet. And kind of there's a few reasons for this. So we would really like, one of the killers for robotics companies is having to call out all the time for maintenance call outs. When you think about it, if you have 10 robots in 10 different facilities and you have to send people out to them all the time, it would be disastrous. Yeah. So what we hope we can do is kind of predict how the robots are being used, so how often they're being used, and try predict kind of maintenance call outs in advance, so we can kind of do an upgrade of all the robots that need to be done at one time. And we really feel that kind of as we grow the number of robots we have into more locations, that this will be a lifesaver. So not only is the kind of infrastructure we're building for logging to be able to tell, how many days the robot's been cleaning or its battery levels or logging any errors, but to actually kind of estimate its usage and be able to anticipate when, an upgrade might be needed. And yeah, so we kind of Akara works as, you might have heard that term, robots as a service.
Yeah, actually, I was going to ask you about that. It really sounds like that's the model that you guys are going with. And as well as, I know, that is kind of, the as a service thing is really, it seems like, a lot of industries are heading that direction.
Yeah, 100. It makes so much more sense for both the consumer and the people building the robots, because the consumers get kind of free upgrades. If there's a new feature, like say you buy a robot and it doesn't have a speech interface, and then the company that sold it to you start building a speech interface. If you use robots as a service, you can just kind of add that onto your robot and then have it. Whereas if you just buy it straight out, you kind of have a depreciated hardware from the day you buy it. So it's really beneficial. And there's kind of also that other aspect of being able to scale. So particularly for us, say, for example, a hospital might have a busy season like flu season or in the winter where they kind of need more robots at a time and need to be able to kind of have rooms cleaner quicker. They can kind of scale up the number of robots they have for the winter season and then kind of scale back down. So it's really beneficial to hospitals, and they have a greater level of support, and we can kind of help on working to improve the robots over time, and continue working with hospitals. So it's kind of a best of both worlds for each the customer and the people building the robots.
So robotics as a service, once again, you've been hearing about, everything as a service, and it sounds like it does make a lot of sense for, especially for big expensive pieces of hardware.
Yeah, exactly. Like you don't want to have something that doesn't work in a few years, or that not even doesn't work, but just doesn't improve along with the technology that's improving.
And, and you had mentioned, and it sounds like, once again, you found another use for artificial intelligence and machine learning in, not only guiding the robot and, making sure it's safe and gets to where it needs to go, but now we're into, predictive maintenance algorithms for when you take the robot offline and do maintenance or whatever. So, AI is just, machine learning has just been layered into, into every aspect of these autonomous mobile robots.
Yeah, exactly. Like once you kind of have the infrastructure set up so that you can kind of get that data, there's so many different ways you can use it, even to predicting like what rooms need to be cleaned more, or, other improvements that can be made. It's all kind of, it is, I know it's such a cliche, but it is kind of about collecting the data to improve the product. I hate that I use that phrase.
Oh, but it is absolutely true. And I think even for you, and I bet your customers would be really interested in seeing some of that data in terms of, okay, what levels of disinfecting are required for different areas of the hospital.
Yeah. So as I kind of touched on before, it's not just a UV disinfection robot we're building. We're trying to build and improve the way hospitals are run and their kind of efficiency of cleaning and facilities management in hospitals. So, a cleaner would typically go into a room and fill out a sheet of paper to mark off what they've cleaned. Whereas, it would be really simple to be able to digitize that and then also have the robot feed into that. And, a lot of facilities spend so much time in hospitals just looking through kind of cleaning schedules and what's been done. It takes a lot of staff resources and people's time, and hospitals are already overrun as it is. So kind of having like digitizing some of the processes and having robots that are kind of recording data to be able to feed back to facilities management managers is really useful.
And we are back live.
Yeah, great.
Wow, I cannot believe that was a year and a half ago. I still remember that talk very clearly.
Yeah, it does not seem like that long ago that we talked last, but since then it just seems like we've changed so much. It was actually really nice to listen back to.
Yeah, I was thinking the exact same thing, just like, wow, okay, because we learned so much about, about what actually goes into an autonomous mobile robot. And so how is Violet, my favorite bot, doing these days? What have you guys been up to?
Yeah, so we've come a long way. So I think when I was talking to you last, we were kind of at MVP and still iterating through design. So since then, we've gone on to achieve the CE mark, which was a huge milestone for us. And not only that, in terms of traction, we've gone from, running pilots to actually our first contract with a UK hospital. So Violet is now, a sellable robot and an operating robot. And then there's kind of been we've expanded out into our offering. So I was kind of alluding to the data at the end of that. We've actually found that that's extremely important to hospitals. So being able to understand, what is happening in their hospital, and kind of having a robot there is almost a surveillance way as well, to be able to tell humans when rooms are ready for the next patient is really extremely useful. And I'm currently now in LA. So we've gotten into the TechStars LA program, and we're targeting the US to be able to replicate what we've done in the UK over here in the US.
So, okay, so you guys are really starting to expand now. I mean, I read about the contract in the UK, which is fabulous. And you're expanding to the US. I mean, it's just,
and our team is a lot bigger. So we have, a lot more engineers, really experienced engineers, and it's really growing now.
That is fantastic. Congratulations on all the successes that you guys have had. And I know you guys have won, tons of awards for the technology behind Violet, your use of AI and machine learning and, in creating, the algorithms required to run the robot. It sounds like you guys are really kind of poised to start taking off and make a real difference in healthcare.
Yeah, for sure. We're really excited about it. And we've won so many awards. I think what we do a little bit different is we actually build everything on our robot from the ground up. So whereas some companies might get an off-the-shelf base and use that, we've really kind of built the full stack.
Yeah, and so you guys really understand it at the true base level of the robot and can make changes. I'm sure do some customizations for various clients and whatnot.
Yeah, exactly. So we're very customer orientated. So we like to say we build with the user, because a lot of technology that's put into hospitals is made by people that haven't actually spent time there. And I and some of my co-founders have actually spent a whole day cleaning hospitals to really understand the problem. And
that's dedication.
Yeah, to understand how difficult it is and how best can our robots help.
That's great. And you guys are still moving forward with your robotics as a service model then?
Yeah, definitely. It's hospitals just prefer it. They don't want to put up a big capital expense to buy this piece of hardware and then, have to have a service contract to maintain it. And we're giving them cleaning. So they're just paying for the cleaning service.
That's fantastic.
And the data on top of that.
Right. Yeah. And like you said, that I can imagine is so critical to really understanding what's happening in the hospital, in that environment, just in general.
Yeah, and actually a lot of robotics companies are finding that their robots are collecting data, obviously not in the same way that people can. So it's a really useful asset to have. Like we were finding that we were turning rooms around a lot quicker, but no one knew. So they didn't have the patient ready to go into this room. So it was still kind of a blocker, where now they kind of have a control system where they can see the patient flow throughout the hospital.
Okay, that's fantastic. And then once again, just opening up new markets and new ways of doing business with the infrastructure.
Yeah, exactly.
That's fantastic. So Niamh, are you ready to take a few questions from our audience?
Yeah, for sure. I see there's some here.
All right, sounds good. Let's dive into it.
Perfect. Thank you, Raymond, and thank you, Niamh. That was a great discussion. I'll go ahead and host the questions here. I see most of them are technical questions for Niamh. So we'll go ahead and get started with these. The first question asks, are there common mapping and navigation sensors besides the TOF, the time of flight kind of sensors like ultrasonic? And are there benefits to using different kinds of sensors?
Yeah, I think different sensors do different things. So like we would use a 2D LiDAR for obstacle detection, but also for localizing the robot. And the benefit of using the LiDAR is it's very high frequency and very reliable. And we can have that safety rated. So we use a 6 safety rated LiDAR. And that kind of ties in with our CE marking and our product safety. And then we use stereo depth cameras for to be able to detect obstacles around the robot as well in 3D. They're a lot cheaper, which is great. Raymond, you probably know.
Oh yeah, no,
Yeah.
we work a lot with Intel and their
Yeah.
real cameras, and it's a great market, and they've got a fantastic product line.
Yeah, they really do. And I think there was maybe when I was talking to you last, they had thought that maybe they were going to pull back on the Intel RealSense development, and I think all the robotics companies freaked out.
They actually do listen.
Yeah.
That's fantastic.
Yeah. So the benefit of that really is the cost. So it's maybe not as reliable. You have to use some software sometimes to smooth out the results. It's a lot of data. It's kind of for shorter range. But yeah, it's definitely a benefit in terms of cost.
And this next question actually might have quite a bit to do with that previous question. It says, talking about AI, because that's kind of been a huge topic of discussion, especially over the last couple of years. How effective has AI become recently at compensating for poor sensor input, filtering out noise, light, those kind of things? And you mentioned some of those challenges in your presentation earlier. Is it possible for software to solve some of those problems rather than just replacing it with more expensive hardware?
Yeah, so there's always been filters that have been used, statistical filters like a Kalman filter or some averaging filter to clean out noisy sensors, or as I said in the talk, you can use sensor values from another sensor to compare. You could use the more advanced, what people are calling AI now, or the more advanced machine learning, where you take data and create a model and apply it to your sensor data and try and improve it based on previous data points. It could, in this case, maybe be a little bit overkill. I think in robotics, you have to be careful about where you're using your compute, and you don't want everyone to have to charge the robot every, hour. So you kind of have to pick where you apply these methods. I think the statistical methods work very well now. So for me, I don't see them changing hugely. Where I see AI models in robotics really taking flight are in terms of kind of the social robots, or these humanoid robots that are coming out, where they're actually learning using Gen AI, and the Toyota Research Institute are creating these large behavior models now, where they're doing household tasks and they're teleoperating the robot to do it, and then the robot can take that information and learn how to apply it to an unknown setting. So I see the kind of AI trend more on that side of things, like a higher level up the stack. For me, I think the statistical models being used now are a good fit for what they do.
And I think, Niamh, I think you hit something that artificial intelligence, machine learning, deep learning, I think those are great tools and great techniques. But once again, I mean, just like you said, they've got to be applied properly and be, you've got to do an analysis of whether it's actually the right way to go with whatever design that you're working on.
Exactly. Yeah.
I think a lot of engineers think, oh my God, it's the latest thing. I've got to go put it in my, widget. And it may not be the right way to go.
Yeah, you're going to be bloated at the end of it.
Exactly.
Yeah, and one of my professors always said, start with the simplest model and then work your way up if it's needed, rather than because you can overtrain. So if you don't have enough data for a very complex model, it's not going to work well. So you always start at the kind of, well, not the lower end, the kind of mid-tier.
Right.
This reminds me of part of your discussion earlier where you were talking about applying a technology like a user interface and thinking that it's going to be the right solution, and then finding out later that it really wasn't an appropriate choice for the situation.
Yeah, you really have to test with your users. So everyone says it that the user is important, but I think people say it and then still assume that they know what the best solution for the user is. And it's easy to do. We've done it. We did it in that situation. So you really have to get it into the hands of users. That can be really hard in healthcare, especially in robotics, because even getting test pilot sites is difficult. These people in hospitals are very overworked. Bringing in a robot and asking them to test it can be too much sometimes. And so we're really appreciative of the pilot sites that have embraced technology and seen it as, the way forward to tackle some of the big issues in hospitals at the moment.
All right, well, our next question has to do with communication. And really quickly, before we get to that, just a reminder to the audience that if you have questions, just be sure to submit those over on that chat box that's over on the right-hand side of the screen. So this question says, is there a projected solution to the communication problem that's in hospitals using things like Bluetooth, 5G, et cetera?
Yeah, so I think if there is, hospitals will be the last place to bring it in because they are just always a bit behind in innovation. The first time they still use pagers. The first time I ever saw a pager was last year in a hospital. So they're often behind because they're so overworked and under pressure. We use Bluetooth for things like the sensors I mentioned in the room, the UV sensors that interact with the robot, and we want to make sure that we're not reliant fully on the hospital's infrastructure. So we've actually started putting in kind of infrastructure of our own, which has helped. So having kind of more control over the technology in the hospital and you providing it has actually been a way around some of the issues we've found with Wi-Fi connections.
So Niamh, you guys are actually installing routers and switches and infrastructure in the hospitals just to kind of shore up their communication infrastructure?
So not actually that, it's more how we use the robot. So we now have kind of tablets in the room that can control the robot and a human can use. And that actually helps them because they can use it for other things like recording human cleaning tasks. So it's kind of like almost like a central unit that a person can use to interact with the robot directly.
Got it. Okay. Yeah, and I know just from a regulatory standpoint, I know the healthcare is often, I don't want to say late to technology, but yeah, there are just so many regulatory hurdles that need to be met, and rightly so, just for patient safety. Yeah, I mean, I didn't realize they were, I guess, for lack of a better word, that far behind.
Yeah, I guess that it's they're so far ahead in terms of medical equipment and that area that it's less of a priority in terms of operational. So how the hospital is kind of running is a little bit further behind. Whereas the medical side obviously is, are using Da Vinci surgical robots and this type of thing. It's more on the operational side that we're starting to see now that there's more of an uptake, because that really is what gets patients in and out of the hospital. And it just hasn't been a priority on their list at the moment, obviously, because people's health is.
Right. That makes total sense. And I mean, they only have so much budget. And like you said, they tend to spend that on the latest medical devices.
Exactly.
Our next question actually has something to do with what you just mentioned with the Da Vinci robot. But the question says, how long do you think it will be until robots are in the operating room assisting surgeons?
Yeah, they are. They are right now. And there's actually a lot of startups now kind of coming after Da Vinci a little bit. So I talked to a startup here that are building kind of smaller versions of the Da Vinci robot that are able to move around to different ORs. But yeah, their surgeons are using it assistively right now. And for me, I think that that's probably the way it will be for a long time, rather than leaving it something that important completely into the hands of a robotic system. I think it should be an aid for now that people use. But yeah, it's allowed surgeons to increase the number of surgeries that they can perform. And it actually as well, they use a lot of data. So they collect data around surgeries. So they're kind of really the leaders in the area, but there are a lot of startups now moving into that space.
Next question asks, do you ever use FPGA devices, or is it always a common platform like a Jetson? And have you ever tried or seen someone else try cloud computing instead of keeping everything on board the mobile device itself?
Yeah, that's a good question. So we did look at that. I think the thing when you're a startup and you've limited engineering resources, that reinventing the wheel and using that type of technology and putting a lot of resources into that doesn't make sense at this time. Using something more off the shelf like a Jetson or a Google Coral or an Intel Movidius compute stick makes more sense for now. But yeah, as we grow and as we start to look more lower at a component level at improving our, bottom line and cost of materials, that could be something that we look at. But right now, a rule in startups is don't reinvent the wheel if you don't have to. But yeah, it is something we would look at. And then in terms of the cloud, so there's kind of two areas there that we identified as possibly running our models on the cloud. One was, and the reason we decided not to was the issues around Wi-Fi in hospitals and, not wanting to rely on having to do that. And then secondly is the kind of safety. So having, data being streamed to the cloud, we're in a hospital, we prefer to just take the detections from the model rather than sending the data actually out of the facility. So they're kind of the two reasons we didn't do that. But in other industries where you can guarantee that there's a Wi-Fi connection and the data you're sending is okay to be stored on a server outside, I think that is a good option.
There's a couple of questions here that have a little bit of context provided along with them too. The first one says, for business, particularly first deployment after tests, is it feasible to offer your service for free to a customer for a certain period in exchange for getting real world feedback and getting the customer more familiar with the robot?
Yeah, that's a really good question. And that's exactly what every startup does. So they're called pilots. Sometimes they can be aided with grants. So if you're if you are interested in starting up a company in robotics, that's what we do all the time. So, we offer the service for free, and it can be a benefit in two ways because it's kind of a try before you buy. So they can test it out, see if it gets it can work in their workflows. And then also it gives us the ability to be able to calculate a return on investment for a hospital. So be able to get the data to show our robot is cleaning this much faster. So it's freeing up this much time at the end of the day, and you can perform X number of extra procedures. And then also on the infection control side for us, we can do microbial testing to show that there actually is a reduction in bacteria and viruses. So it's really important when you're an unproven startup to be able to collect that data, and you offering that service for free is the way that you can do that.
And again, this next question does have some context to it. It's a user with a very specific application, so it may require just a little bit of follow-up afterwards with this particular user, but he poses some really good questions. It says, not sure if you have experience in the automotive manufacturing world. I know that you've mainly been talking about healthcare in this presentation, but I've looked into implementing autonomous material handlers in this environment. The trouble I run into is finding the resources to create the fundamental structures necessary for this to work. What kind of support does your company offer to help create those structures? Things like defining routes, how to handle materials of different kinds and multiple crates, how to best call for materials when needed. We also need to have a system that works both inside on nice flat concrete and outside on less than ideal surfaces. And this has been an issue when working with other companies. And are there options available that can handle these different environments?
Yeah, okay. So just so I can iterate that back, not